So what does f of x mean? A function of x, right? A function, it tells you right off the bat it's in function notation, and so it's f of x. We're talking about a function and we're using the variable of x. What else can we say f of x is the same as? Y. Okay? Is that always true? No. When is it not true? Upper level math classes that we don't get to in high school. Okay? In upper level math classes, f of x and y are not always the same. But for us in high school, especially in Algebra 2, they're the same. You okay with that? Okay. So if I say f of x equals x or y equals x, do you remember what kind of function that is? What its name is? That's a linear parent function. Remember, it's a parent because nothing's being added, subtracted, or multiplied to it, and it's like the original shape of the function. Okay? Now, I don't quite know you guys very well yet to know what kind of learners you are, so right now I'm going to teach you if you were a visual learner, because that's what kind of learner I am. Is that fair? Okay? So first thing I want to do after figuring out what kind of function is, I want to go look at it. So let's complete this side of the worksheet first. Okay? Let's fill in some values for x because that's the independent variable, so we get to choose what we want x to be. And if it's okay with you, I'm going to choose -2, -1, 0, 1, and 2. If it's not okay with you, that's still what I'm going to choose. Just saying. Okay? So if f of x equals x or y equals x, and I know x is -2, what's y? -2. And what if x is -1? -1 and 0 and 1 and 2. Excellent. Can you plot those points on this graph? Please do it. Now, does yours look like mine? Did you do anything else that I didn't do? Nobody did? What do you think? What do you think? Other people might have tried to put a line through it, right? So I'm asking you right now is, are we allowed to do that? Are we allowed to connect these points like into a line? How do you know we can? It is a linear function, and how do you know that? It gave us the equation, right? When it gave us the equation, we are able to assume that it is a function and we can connect the dots. Can I do it incorrectly? I'm going to do it incorrectly for you. Are you ready? Why is that incorrect? I know it continues. I know it goes on and on because it's a function. So I want to take it to the edge of the graph. Okay? I'm smart enough to know that it goes to the end of the graph, so I'm going to take it to the edge of the graph. Okay? Now, in general, not talking about this specific graph, but in general, an x-intercept is always going to be something 0. Because if it's x-intercept, it's on the x-axis, and any point on the x-axis has a y-coordinate of 0. Do you agree with that? Good, because I'm right. What about the y-intercept? What does it look like? 0 something, right? Like that. Now look at this specific graph and tell me, where does this blue line cross the x-axis? Okay, but where does it cross the y-axis? So you're telling me this particular parent function has an x and a y-intercept that's exactly the same point? Is that allowed? Yeah, we just proved that it was, right? We just found both and they happen to be the same point. Okay? Let's talk about the domain and the range. Do you remember talking about domain and range in Algebra 1? Good, because I know you did. Okay? What do you remember about domain? It's the x. So what's the range? The y. Okay. So domain. Okay, domain, which direct? It's x, so which direction is that? Horizontal, so it's left and right. You agree with that? So one way to think about domain is to think this graph, how far to the left does it go? It goes all the way, right? How far to the right does it go? All the way. So you wrote domain and range in inequality notation in Algebra 1, which I 100% support because that's what you needed to do for Algebra 1, okay? For Algebra 2, we need to know two different ways to write domain and range, okay? The first way is inequality notation, which you're used to, and if I'm not mistaken, this is what you wrote because it went all the way to the left and all the way to the right because that means all real numbers. Very good, okay? Also in Algebra 2, though, we need to be able to write interval notation. If you're not quite sure about interval notation, even though we talk about it for the next couple days, please don't worry because next week we're going to spend some time on interval notation because it's that important. Okay? Here's what interval notation looks like for this graph. You told me it goes all the way to the left and all the way to the right. So I'm saying negative infinity to positive infinity. Okay? So what about the range? If domain is left and right, what is range? Okay, so I agree with those of you who said vertical, but some other of you said something else, and I'm going to be a little picky about this. Can you let me do that for a moment? If domain is left and right, range is it's down and up. Why would I make you say down and up? Negative to positive. That's exactly right. Okay? I know it seems picky, but I don't care. Okay? I want us to think negative to positive, negative to positive. Okay? So how far down does this function go? And then up? So does it look exactly the same as the domain? All right. Well, please write it that way. Some people earlier were having trouble with their infinity signs. And so I was like just suggesting just turn your paper sideways and draw an 8. Or you could just like grow up a little bit and learn to draw an infinity sign. That's all. Not judging you. I'm just telling you we're going to draw them some this year, so learn how to do it. Fair? All right. What do you know about these two words right here? So you know how to read them? Excellent. Okay. Continuous or discrete? Is this function continuous or discrete? How do you know it's continuous? Okay, so timeout. I have to make a timeout here. Okay? What you're telling me is that it's a continuing function because it goes on forever. It's a continuing. It continues. That is not the same thing as a continuous function. I need to make sure we stop that right now. Okay? A continuous function says that every point on this line, including the ones in between the dots that we made based on our table, also makes this function true. If I say x is negative 2.637, what's y? Negative 2.637, right? So every point in between the ones that we've made also make this function true, so this is a continuous function. Okay? Now, another way that we know it's continuous is that it was given to us as a function. Okay? It was given to us f of x equals x. There are some things that are given to us as a function that are not continuous, but we'll talk about those when we get there. For the most part, functions like this are continuous. Okay? Again, I'm not saying it's all the time that that's true because it's not, but for the most part, if you've got an equation that you're given, that's going to be a continuous function. What does it look like if it's discrete? It's a bunch of dots. It's like dot, 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 and they're not connected. It's discrete data. It's like individual points of data. Does that help? Okay. Now, I need you to understand that this next one right here, this one is upper level Algebra 2 stuff. Okay. We are not going to talk about it today, and we're not going to talk about this box on any of these until we completely finish the worksheet. I want us to have an idea about general functions before we go there. Are you okay with that? I'm not saying you were stupid, because if I was, I would just flat out say you were stupid. I'm not saying that. Okay? I'm saying we're not ready for this quite yet. Is that okay? Maximum and minimum. Any ideas what those words mean? highest and the lowest, right? That seems pretty obvious, right? I try to trick you sometimes, just being clear, okay? So tell me what the maximum point is of this function. So tell me then what you think about what somebody said earlier, because they said 10, 10. Like right there. Is 10, 10 the maximum of this graph? Yes. Is it the maximum of the function? No. You know because of this arrow that it keeps going, right? So some of you even said that the maximum is infinity, right? But do you know where infinity ends? So we don't want to say infinity either. We just want to say it doesn't have one. Because by saying infinity, you're almost implying that you know where that is, and I don't. Okay? What about a minimum? It doesn't have one. Same reasoning, right? Okay. Intervals of increase and decrease. We are specifically talking about the domain here, the x values. What x values are increasing and where on the graph are the x values decreasing? So let's think about this. When we're talking about increasing and decreasing, we are talking about from left to right. Not from middle and out, but left to right specifically. So if I start on the left side of this graph and go to the right side, where is it increasing? So only this part right here is increasing? Isn't the whole part increasing? So on the whole domain, it's increasing. Well, what's the whole domain? Negative to positive infinity, right? So here's a trick question. Are you ready for it? I'm telling you ahead of time that it's a trick. Where is the interval of decrease? So from here to here, it's decreasing? I don't read it like that, do I? How do I read it? Left to right. So tell me where it's decreasing if we're reading it from left to right. It's not. We're allowed to have no interval of decrease. If it's already increasing everywhere, where can it be decreasing? No, it doesn't. Okay? It's okay. Now, remember how I told you a little while ago that a lot of the stuff that we do in the first couple weeks is stuff you've already seen before? This is one that you have not. You have talked about this before, but not with this notation. So, can I explain the notation? I'm just going to translate real quick. I don't know if you guys know this about me, but I'm bilingual. I can speak English and algebra. Okay? So here's what this says. As x is going toward negative infinity, so as my x values are decreasing, what is happening to my y values? Aren't they also decreasing? They're going this way. So it is approaching negative infinity. As my x's are decreasing, my y's are decreasing. Does that make sense? Okay. As my x's are increasing, what is happening to my y's? They are all increasing, also increasing, so what am I going to write right here? Positive infinity or just infinity. Okay. So we are finished with the first part, the first section, and I have to tell you something up there is wrong. Kind of. Mathematically, it's kind of wrong. But we're going to leave it because that's how we're going to do it. So can I explain that? Explain what I mean? Okay. There's no such thing as negative infinity. But we wrote it here, and we wrote it here, and here, and here, and here. Why would we write negative infinity if there's no such thing as negative infinity? We're talking about a direction, aren't we? It's like a notation that we can use. Infinity is just infinity. It's just that way, right? But if I give myself a negative in front of my infinity sign, I know specifically I'm either talking about to the left or down. Okay? So don't be afraid to write negative infinity, because if you talk to like a super smart mathematician like myself, I would tell you there's no such thing as negative infinity. That's the notation that we can use to tell ourselves we're talking about to the left or down. Does that make sense? Yes, ma'am. It'll be that way too. Yep. Mathematicians use it as a notation, but we know infinity is just infinity. This gives us a direction to know that what we're talking about. Does that make sense? Okay. Okay so far? Anybody have any questions? Okay, let's go on to the next one then. What do you think this is called? Absolute value. Excellent. If I can spell absolute value correctly, that would be nice. What do you want to do first? X and Y? So what do you want to use for X's? How about if we choose some negatives and some positives? Is that okay? Does it matter? Right now, not so much. Okay. So is it okay if we just use the same ones as before? Excellent. There, that's better. If X is negative 2, what's the absolute value of negative 2? How do you know that? Oh, it's always the opposite? It's the distance from 0, and because it's a distance from 0, it's not negative, because we don't have negative distances. You okay with that? So if X is negative 1, what's the absolute value of negative 1? 1, 0, 1. Are you sure it's not negative 1? It can't be negative. So even though negative 1 is 1, 1 is still 1, right? It's not an opposite thing. It's a distance thing. So can you please plot these points on the graph? What do you think? Can we connect them? Are you positive? What's the absolute value of 1.36? So do all the points in between these points also work? Yes. So can I connect them? So what else can I do real quick? I can circle continuous, can't I? Okay. What about x-intercept and y-intercept in this case? They're both at 0, 0, aren't they? Good. What about domain and range? How far to the left does it go? And then, okay, so all real numbers? And then negative infinity to positive infinity? So same thing for range? How far down does it go? Does it? Oh, it stops, doesn't it? It stops at 0. There's no negative values. You guys just told me that, didn't you? So there's no negative y values. How far up does it go? Forever. So y is greater than or equal to 0. And the way we write that in interval notation is 0 to infinity. Okay with that? What's the maximum? None? Why? Okay, what's the minimum? Okay, so I have to be picky about that. What do you mean by saying 0 is the minimum? Yeah, that's right. Okay. So technically, I understand what you're saying by saying 0 is the lowest it'll go, but we're looking for the minimum point. And the minimum point is 0, 0. Okay? There's a lot of stuff I have to be picky on because I just need you to use the correct vocabulary. Is that fair? Okay? Intervals of increase. So as we're going from left to right, is it constantly increasing? So this right here is increasing. It's decreasing. If you think about starting here and going this way, that's increasing, right? But what were we clear on before? Left to right. Okay, so where is it increasing in left to right? Only right here. Very good. Now, we have to talk about this. I'm telling you this is the right answer. We'll talk about it in a second. Okay? Where is it decreasing? You guys, man, you guys have gotten this spot on today, and I'm pretty proud of that, just for the record. I didn't have anything to do with it. It's your intelligence, but I'm pretty proud that you said it. Okay? Because a lot of people say, oh, it's 0 to negative infinity. Except we're going to left to right, aren't we? And so you said negative infinity to 0, and I'm just really happy about that. Okay? So here's what we need to talk about real quick before we go on. Okay? We said that the range was 0 to infinity. And I have a bracket on my range because that point 0 is included as part of my range, right? Why do I have a parenthesis when I'm talking about this in my domain, 0 to infinity? Can a point be increasing or decreasing? It's only after that point that can be increasing or decreasing, right? And so it starts at 0, but we can't include 0 because 0 is that point where it's where it starts the increase. So when we're talking about intervals of increase or decrease, I'll just make it really easy on you. We won't ever have brackets there. There'll always be parentheses there. Okay? And what about the last part? As x is going to the negative infinity, what's happening to the y values? It's rising, so it's going to in positive infinity, right? And as x is increasing, what's happening to the y values? Also going to positive infinity. Now, before the bell rings, here's what I need you to know. These two, the x squared and the x cubed, this needs to be done before you get to class tomorrow. I know I don't want to use the dreaded H work on the first day of school, but it's homework. Okay? Use the first two as an example. I'm not asking for the whole packet. I'm just asking for the back two on the first page. Okay? Just asking for the back two on the first page. I hope you had an amazing first day of school, and I will see you tomorrow.